and welcome to another Unity 5 tutorial. This tutorial is going to be a really quick one. It was a message I received today from Eric Weeks, who wants to know how we can adjust this skeleton model so that the field of view that he's looking for actually comes from his head. So in the previous tutorial from this one, we took this skeleton model and we checked the forward axis of the model, and then if the player was standing within 30 degrees of this axis, then the skeleton would see us. So if I just run this to give you an idea, if you're interested in how to put this project together to this point, you'll need to go back and look at the first version of the line of sight artificial intelligence tutorial. Okay, so he's standing there and we can walk around behind him and we can get quite close from behind. We can get right up near and he won't even notice us until we're around the front. So once we become 30 degrees in line with him, his actual zero position, which is on the ground facing forward, then he's going to attack us. But the thing with this particular model is that his head moves around. So if we just play it again and have a look at his head, you can see just over here, the point that 30 degrees is being taken from is facing in this direction, and his head actually moves around. So it would be kind of more realistic if we used his head to determine the direction. Right, so how do we do this? First of all, we need to get the vector system that's working with his head. So if we go to the hierarchy and have a look through our skeleton model, we can start to pull it apart and look at all the different bits. Now, with humanoids, they usually have a pretty standard structure. So you've got the pelvis point, which then leads up to a spine, and it will have both thighs attached to it. And you can see those changing over in the scene view. And then the spine will go up further to the neck, and eventually we get to the head. And it's the head that we want to work with. Now, the issue with the head is if you look at its axis system, it's not the same as the body. So the body itself had the blue axis, which is our Z axis or our forward axis, facing forward. The head, which I'm going to have to grab through the hierarchy again. Where is it? There. As you can see, if we're getting close, it's the green axis that is facing forward. And if we play this, we can just watch the head and the axis system of the head moving around. Notice that green axis is the one that's facing forward, and it determines on whether your character is going to see you or not. Alright, so let's stop playing. What is the green axis? Well, we know that the blue axis is the Z axis. And we know that if we look up here at this little gizmo, you'll eventually get used to the coloring system of these. The green axis is the Y axis, so that's our up axis. The head in this case is obviously facing the wrong way for using as a forward movement. So we need to always refer to our 30-degree angle that we want to use for whether it sees us or not using the up axis. Okay, time to look at the code. So if we go back to the code, this is the code that we had before. It hasn't been modified. Oh, I'm lying to you. It has been modified in anticipation of what we're about to do. This line here has moved. So this direction y = 0 was down here, I believe, or might have been here. Anyway, it was somewhere inside of there. Just move it up to this position. So we're going to have the y direction being superfluous as far as the direction again. Alright, so we've got this angle that we're calculating, and it's this angle that we're testing is less than 30, which will then set the skeleton to attack us. But it's determining the angle based on the forward direction of the whole skeleton. Okay, but remember this code is attached to the skeleton. What we need to do is grab hold of the skeleton's head, and I'm going to pass that through as an exposed variable at the top, and we only need the transform. Now, once we've got the head, we can then use the head to work out the angle. And it's head dot, not forward anymore because we're using that green axis, so it's up. So if there's a 30-degree angle between the head and the up axis, between the up axis of the head and us, then it's going to start attacking. So if I just save that and flip back into Unity, now we've added that exposed variable for the head. So if we select the skeleton, have a look in the inspector and you'll see that the head is here. You want to grab the head object and just dump it into there. So we can now use its orientation in the code. So let's run this and see what happens. So press play. Now we're going to wander up to this guy. I'm going to go to the side so that he won't come towards us until he's looking at us. Okay. Right. Now, what's going on here? There's something really wrong with the way that he's moving. And that's because his head, unlike his body, moves around a lot. So each time that angle of his head to the player changes outside of that 30 range, then he's going to switch back and forward between animations, which is not what you want. So we want to set some kind of a value to say, yes, he's seen us, and therefore if he's seen us, he'll keep pursuing us, even if his head happens to be sort of facing the other way, okay? He's still sort of intelligent enough that he knows we're still there and will keep walking towards us. So we're going to add a Boolean value into our code to keep track of when that happens. So let's go back into the code. At the top of the code, we'll create a bool, and let's call that pursuing, and let's set that to false to start with. And down here, for our test, we're going to test it that we're within 10 of the character and that the angle is less than 30, or we're pursuing. So the first time we come into range, this if statement will trigger because angle has become less than 30. Pursuing will still be false because there's nothing else that can change it to true. And because this is an or statement, it only needs the angle to be less than 30 to trigger. So once this does trigger, we then inside here will set pursuing equal to true. And that will mean that even when the angle goes outside of this 30, it will still keep pursuing because this will now be the triggering value in this or statement. And then finally, when we go back to idle, we need to set pursuing back to false so that he doesn't keep trying to walk towards us. All right, so let's save that, switch back, and we'll run it. Now, I should be able to sneak around to the side and we'll just see if he looks at us. Yeah, okay, so he's looking towards us. Now, once we get within range to here, once he's turned around, he sees us and he comes directly for us and starts attacking. So it's working exactly like we wanted. And that's it. Nice, short and sweet, easy answer. The important thing with directions and working out angles between things is really make sure that you know what transform is sitting on which part of the model, because sometimes those models don't have the z-axis facing forward, as you could see with his head, and that makes an absolute huge difference to the way things work. Okay, so hope you enjoyed that. Eric, thanks again for the idea. And if you've also put any requests through for tutorials, don't fear, I have a long list of them and I am slowly working through them. This was just very short and sweet, so it was easy to do. And I'll talk to you next time.